Example 1 here on the quadratic formula is taking a look at actually using the quadratic formula. And we're asked to find the solutions to the quadratic equation given here on the screen now, giving our answers in third form. Now here, what I'd always do when doing a question of this type is write down our a, b and c values. So to start with, we can see a here is the coefficient of x squared, which is 3. Our b is the coefficient of the x here, which is minus 8. And finally c is our final term here, so that's plus 2 there. Now here, we're just simply going to use the quadratic formula here to find the solutions to this quadratic equation. So therefore, x is simply given here using the quadratic formula. So that's going to be minus b, so that's minus 8, so minus 8 here, plus or minus the square root. So the first part here is b squared, so that's going to be minus 8 squared, minus then 4ac. So I like to put this all in one bracket here just to be careful for negatives. So this is 4 times by a, which is 3, and then times by c, which is 2. Okay. And then finally, this is all divided by 2a. So that's going to be 2 times by a. So if a is 3, 2 times by 3, giving us 6 there. And then here, at this stage now, it's just a matter of simplifying where we can. So minus 8 will give us positive 8. So that part there is 8. We have plus or minus here, the square root. So that's going to be 64 here. And 4 times by 3 times by 2 gives us 24. So that's 64 minus 24, giving us the square root of 40. And remember, this is all divided by 6. And here now, we just need to take a look at this square root of 40 and see if we can simplify this. And we absolutely can. The square root of 40, we can write that as the square root of 4 times by the square root of 10. And the square root of 4 we know is simply 2 there. So this is 2 times the square root of 10. So what we can do here now is rewrite this as a plus or minus 2 root 10 divided by 6. And then finally here, what we can do is divide our numerator and denominator here by 2, just to simplify our final solution here. So therefore, we can write our final solution here as 4 plus or minus root 10, because it's 2 root 10, so we divide that by 2, we just obtain root 10. And finally, we have a 6 in the denominator here, so again, if we half that, if we divide it by 2, we just simply get 3 there. And in that case, we obtain our two solutions then to the quadratic equation 3x squared minus 8x plus 2 equals 0 in third form here. So x is equal to 4 plus root 10 divided by 3, and x is equal to 4 minus root 10 divided by 3. And that gives us the solution to example 1 there. Moving on to example 2 now, which is taking a look at finding the discriminant. So here we're asked to find how many real roots does the quadratic equation 2x squared minus 5x plus 3 have. And in this case, again, just like we did with the previous example for the quadratic formula, I'm going to denote the values for a, b and c here. And remember, a is the coefficient of x squared, so that's simply 2 here. B is the coefficient of the x, so that's minus 5. And finally, c is our final term here of 3. Now, if we're using the discriminant, let's just note the formula for the discriminant. And the discriminant here, d, is given by b squared minus 4ac here. So in this case, all we simply need to do then is substitute our values for b, a and c appropriately into this formula, and then we can deduce, based on our solution, how many roots, or how many real roots, this quadratic equation has. So therefore, this is going to be minus 5 squared minus, and then again, I'm going to put this all into one bracket here, just to eliminate any potential errors with the negative signs. This is going to be 4 times by a, which is 2, times by c, which is 3. Well here, minus 5 squared gives us 25, And 4 times by 2 gives us 8, times by 3 gives us 24. So we obtain 25 minus 24. And 25 minus 24 simply gives us 1 there. Now in this case, remember we compare this to 0. So we check whether our value is either greater than 0, whether it's equal to 0, or whether it's less than 0. And clearly, 1 is greater than 0. So therefore, what we can say is that our quadratic equation, 2x squared minus 5x plus 3, has 2 real roots. It has 2 real roots, and we know that because our value here for the discriminant was greater than 0. So if it's greater than 0, we have 2 real roots there. So that gives us the solution to example 2 there. Example 3 here is taking a look at using the discriminant. So we've been given the function here f of x, which is equal to 2x squared plus 4x plus k. And we're asked to find the values of k for which f of x equals 0 has no real roots. Now straight away we should be aware of the fact that if this has no real roots, what that means is that the discriminant is less than 0. So what we're saying here is b squared minus 4ac is less than 0. Now in this case here, again just like we've done for the previous 2 examples here, let's denote the values of a, b and c. So a here is simply 2, b is simply the coefficient of the x here, which is 4, and finally for c here, it's just this final term, which is k. So we've got a, b and c here. All we need to do now is substitute the values appropriately into our discriminant here. So therefore, b squared, that's going to give us 4 squared here, minus 4ac. And again, let's place this all in one bracket just to eliminate any errors with the negative signs. So this is going to be 4 times by a, which is 2, times by c, which is k. And as we've already noted, as this has no real roots, the discriminant here must be less than 0. Okay. So here now, if we simplify everything that we have so far, 4 squared is 16. And then the bracket here, 4 times 2 gives us 8, times by k gives us 8k. So this is 16 minus 8k is less than 0. And all we need to do now is solve this inequality here for k. So in that case, 16 is less than 8k. Or the other way you could think about that is that 8k must be greater than 16. Okay, these are equivalent. And therefore, if we just want the value of k here, the range of values that satisfy this inequality, then we just divide by the coefficient here of k. So therefore, k is simply greater than 16 over 8, giving us 2 there. So that gives us the solution to example 3. Moving on to our final example then, on using the discriminant. And what we've got here is our quadratic kx squared plus 2kx plus 3 equals 0. We're told this has 2 distinct real roots, and we're asked to find the set of values for which k satisfies this. So here in this case, what we'll know is the fact that we have 2 distinct real roots, and if we have 2 distinct real roots, then what that tells us is the discriminant here, b squared minus 4ac, must be greater than 0. And again, just like we did with the previous examples, I'm also going to denote the values of a, b and c here for our quadratic. So a is simply k, b will be 2k, and c will be 3. So we just put commas in here just so we don't confuse ourselves. So a is equal to k, b is equal to 2k, and c is equal to 3. And all we need to do now is substitute these values into our discriminant. So if we do that, what we obtain here is 2k squared minus 4 times by a, which is k, times by c, which is 3. And this is all greater than 0. So here, if we simplify where we can here, 2k squared gives us 4k squared minus, and if we simplify the inside this bracket here, we obtain 4 times 3, which is 12, times by k, giving us minus 12k here. This is greater than 0. Now here we're looking to find the set of values for which k satisfies this quadratic inequality here. So in this case, we can sketch this quadratic if we'd like, or you could go straight now to giving the solution if you can spot it. In this case here, we'll actually give the solution first, and then we'll also draw an example here of the quadratic. In this case here now, for this quadratic inequality, what we obtain for our solutions here is that k is less than 0 or k is greater than 3. And if we draw a rough sketch here of this quadratic, again, it doesn't have to be perfect, just so we can see what we have. That's our x-axis there. Well, if we factorise here, what we'd obtain then is 4k times k minus 3. This is greater than 0. So what we know then is this quadratic cuts through the origin here, and it also cuts through 3 here. Okay. Well, in that case now, if we know where it cuts through here, we can draw a rough sketch. Let's say it looks like that. And then we can evaluate here using the fact that k this inequality here must be greater than 0. So we're looking where is it above the x-axis. Well, we can see two solutions here. We've got everything to the left of this point here. And we've got everything to the right of this point here. And if we notice, this point here was when k is equal to 3, and this point here was the origin. So in that case, we're saying anything less than 0 and anything greater than 3 there. And that gives us the solution to example 4.